is going to say, because there is no prediction model. So you can plan your work into different kinds of things, because nanoparticle without a fiber you can plan, with the fiber you can plan. So first we can, if you're planning just nano composites without any fibers, you can say that your maximum erosion happens at 15-degree angle. That's a universally accepted thing. Your like if you are having nano composites that are polymers, you will have a ductile erosion behavior. Usually ductile means you will get the maximum erosion at 15 degrees. And when you are coming towards the 90-degree impingement angle, I am telling about the impingement angle, your erosion will actually reduce. You can have a very good study on this one. Different equations are also there connecting the material property and the test parameter, those kinds, because you have to connect your material property and your test parameters to actually predict your mechanism. So this kind of lip formation is there, this kind of tearing formation is there. This all depend upon what your nanoparticles are. So this is the thing, like 15-degree, 30-degree, 45-degree, 90-degree, different kind of experiments you can do. First one is pure epoxies. I have incorporated MOS2, MWCND, hybrids. And finally, we are saying like, okay, our one hybrid is having very good properties. And suppose your hybrid is having good tensile property and tensile and good erosion property, then you can say, okay, this material is going to give you better application oriented areas, because it's not only giving you tensile strength, it's not only giving you flexural strength, it's giving you erosion properties also. You have to have a good idea about the FSM images also at that time, because only in an FSM image, FSM means field emission scanning electron microscope. FSM image only you will get an idea. This image is at a 15-degree impingement angle. What mechanism is actually happen? If it is micro plowing mechanism, if it is micro cutting mechanism, what your nanoparticle will, how your nanoparticle will affect. Those kinds of beautiful images you will only understand from FSM analysis. So this is an image of 90-degree impingement angle. This was an image of 15-degree. The 15-degree just similar to how a water flows in a river. You will see different river-like patterns. But in the case of a 90 degrees, it will be like a moon structure. It's a deformed structure that is having a lot of cracks. So this is 90 degrees, totally different FSM images. If you are very interested in FSM fracture mechanism, if you closely studying these things, you will see what are the mechanisms that are there. And one important thing I have to tell to all the listeners are that once you compare two FSM images, you have to compare similar magnification. Like a material with a magnification and another material with a totally different magnification should not be compared together. That's the thumb rule actually for finding out the mechanism. If you are going to compare two different mechanism with the two different magnification, what use is there? Like it's similar to looking moon from the earth. From the earth, you can see the moon. It's a rough surface. In the stratosphere, if you are going to look there, also you can see the moon, but it's a totally different thing. That's the game that is going to happen. Compare same magnification image every time. So these kinds of studies can be done. I am not rigorously going through because of the time limitation. I am not rigorously going through that erosion things. But this is a huge research opportunity. You can have a good research paper with the BTech curriculum. I know that BTech in Kerala Technical University is like 3 months to 4 months. But I should say, like in the 4 months, students have completed two different works. I should congratulate those students. They have completed two different works and two different SCI papers they have published. If we can guide those kind of interested students, it's good for our faculties also. So till now I have spoke or about matrix modification. Why you cannot modify carbon fibers itself? Because in the company, most industries don't expect you people like go to the company and mix 1 kg of MOS2 in 100 liters of this resin. It is a very tedious thing. then in a company point of view or an industry point of view, how you can better include the things. So now the thing or the now the research interest move towards fiber modification. Rather than putting this nanoparticles into matrix, you can actually prepare your fibers. And this fibers, if you are a supplier, just imagine you are going to start an industry. If you are a supplier, actually, unfortunately, in India, very low suppliers of carbon fibers are there because India, till now, most of the carbon fibers are coming from China. We are just weaving the thing in India and we are supplying it. And India, as the central government is saying, by the next 15 years, we'll be the major carbon fiber manufacturer. So, extra itself, I have seen a news like that. So you can coat your carbon fiber with different types of nanoparticle. Those nanoparticle coating will be basically a chemical reaction that is going to happen. You can try this chemical reaction of salinization technique. Salinization means you can incorporate different chemicals like GPTMS, glycoside salines. So you can incorporate those different kinds of silines. You can coat your fiber perfectly. I will just show how the fiber coating. This is a conventional fiber that we buy from from the industry. This is a fiber that has been coated with a MWCND. This is a fiber that is coated with MOS2. See, this is a fiber that is perfectly coated with a hybrid. So any kind of fibers can be prepared. If you have a good coating technique, you can prepare the fibers. You will send it to you or sell it to a good supplier in India. They will be forced to buy the things, and you can make a start an industry your own also. So this is the equipment setup we are having. This is an infusion setup. One important thing is that 6 different types of compensation was prepared at the same time. It was just like if you are spending 1 day on a manufacturing, you can do 6 different composites. 6 different composites itself will give you easily one good research paper on that. So this kinds of all things are there, like vacuum infusion. You can easily do the things. This is a FSM image, and once you are going to do interfacial modification, you have to do an ILSS. Interlaminar shear stress also you have to do, because that's the correct test that will give you how your interfacial property have improved. Threshold test will give you how your overall property have improved. It won't give you a correct idea about your interfacial property. So these kinds of tests you can incorporate in your study. And this itself, I have shown a fractional test and ILS test. When you coat MOS2, the property is going to increase. MWCND, it is going to further increase, and hybrid, it is going to give you a better property. That was the major findings of our. So this kinds of representation you can do. You can tabulate them as a bar diagram. You can tabulate it as a stress strain diagram. You have to take care about in the bar diagram. You have to put your deviation also. Most of the journals ask for these things very clearly. And this samples. These are the what the recent of my recent students have done. They have done erosion studies on carbon fibers, and they are saying like in carbon fiber, this unlike nano composites where it was having 15° as the highest erosion angle, carbon fiber have 90° as the erosion angle. Just imagine your property have totally been inversed. In a carbon fiber composites, your maximum erosion happen at 90°. In a nano composite that is not having carbon fiber, it is having at 15°. Nano composites actually shows better properties than carbon fiber. When you are thinking like carbon fiber is going to give you big mechanical properties, it is almost having 10 times lower erosion properties. So this all problems are arising, and this is a simple setup. This is a regular carbon fiber. This is a carbon fiber that I have coated with the epoxy. You can do coatings also there. And this work actually I have patented it. Apart from the research publication, we are having a research patent also. This process patent, they have coated this carbon fiber with a special type of coating, and they are proving like our coating will give you metal strength. Maybe the coating will be having weight constraints, but that all depend upon how you are going to apply the coating. So this kinds of work can be done beautifully. You can say like a carbon fiber is having totally, see the carbon fiber at 90 degrees is having 990 erosion rate, whereas a pure epoxy is only having 100 erosion rate. But your epoxy is having strength of 50 megapascal nearly. Carbon fiber will be having 500 to 700 megapascal strength. That huge variation is going to happen. So these kinds of images you can take, you can different kind of, this is 15-degree impingement, this is 90-degree impingement, this is the photos that I have taken from my regular phone only. These kinds of images have been taken. You can actually, you don't need very complicated equipment even. If you are having a good phone, you just take the photos of the erosion samples. At least you can start your work from there. So these are the publications that we had made on the thing. I will share the PPT. You can go through our publication, and if you are having any doubts, you can feel free to contact us. N number of publications from the guidance of Dr. Srikanth sir has been published in this area of infusion. My co-scholars have worked on different types of nanoparticle. I was basically looking into erosion. They have done EMI shielding properties. They have done conductivity properties. Different types of opportunities are there. And I should say I am having like 3 more minutes. This is the last slide I am going to show because all this AI is getting infiltrated. I should tell that thing very frankly. Maybe we are hardcore mechanical people. We loved mechanical engineering. That was the reason why I ended up in mechanical. But current scenario is like you have to be having some computer science knowledge also. It's totally in different department. I know the thing, but at the end of the day, if you are planning for a good research proposal like SERB, DST, you have to have this papers. I feel like now also good car, good mechanical paper that are purely experiment oriented are coming out. We ourselves are publishing 5 to 10 papers every year. So those problems are not there. But if you are planning for a good postdoc or a good DST project, a funding national project, then this AI also had to be incorporated. And I am not compelling anyone. Like if you are clever enough, just include a computer science expert in your team. That's the only thing that is needed. Because similar to mechanical engineering, nowadays every college is having AML department also. If you have a good contact, if you are having a good person who is having a taste, actually there is no need to study from the scratch what is AI, what is Python. For me, clearly, if I am thinking in that way, I will incorporate an additional member into my team. So what are the opportunities? What are the opportunity? How we can take help from this computer science department, AI specialists? So we can have different types of design optimization. This AI and NDT is having a very huge postdoctoral opportunity, like drone visualization, ultrasound testing techniques, different kind. Those NDT techniques are right now incorporating AI also. So you are having X number of input, you are having one or two outputs, you can optimize them and finally say, okay, with this input, this is the maximum property or this is the best thing that we are going to get. So AI in material science is a possibility. AI in NDT, you have to be like civil people also can do the thing easily. Then electronics guys, they can incorporate sensor measurements in the wind turbine blades. You can use AI. Then blade, long life of the blade you can study or through a management aspects. So digital twin opportunities are there. So using AI, deep learning, machine learning techniques, there are opportunities. But I should say like my research interest was more oriented towards this manufacturing aspects because at the you can say our materials is showing different properties, but actually, are you sure your manufacturing technique is correct? That's the bottom line question that I am asking everyone, every manufacturing guys. Is there any manufacturing defect still existing in your problem, in your thing? Once your manufacturing comes into very optimal way, you can say like without even incorporating different nanoparticle, your manufacturing aspects itself, if you can optimize, you can have a very good thing. So this was my last slide. Thank you everyone for your time. And I think some of the queries, if you are having any, I can help you in my knowledge, or I can take some time and I will reply you back also. And that's the thing. That's the thing. Actually, I am just taking this opportunity to thank the coordinators for conducting this thing, for inviting us, and in back in return, I am happy to invite you all to our college. Just contact me in the area of polymer composites if you have any doubts, of your if you want any assistance in preparation. We are doing consultancy works. Opportunities are wide open. You can play around with this. Okay, thank you everyone. Umadat sir, I think my section is winding out. Can you hear me?
Yeah, Arun, we can hear.
Yeah,
So
sir. I am just stop.
actually,
Okay. I
mm,
will just be online. Just can you can take forward, sir. You can take forward.
yeah. Before anyone else, I have one doubt. Uh,
Hmm.
there was one slide regarding manufacturing hybrid. I think
Hmm.
molybdenum disulfide and
Hmm.
MWCNT. But in that reaction, I was seeing some other chemical, some long names.
Yeah, sir. Yes.
So what is that material actually? In the next slide, it seems
Yes, sir. Yes. Here
16
also.
or
Here
some.
also.
Yeah, that
Yes.
ratio. What is that
Sir,
one?
actually, MOS2 you can buy two ways. Two ways you can face this problem. One way is you can buy MOS2 directly from the market. But you cannot control the layer thickness at that time. Just A and B mixing cement and rubble, that kind of mixing only is going to. It's not an in situ reaction. Actually, you are buying two hybrids from the outside. But if you know the precursors of MOS2, how this MOS2 was prepared, and this equation is giving in like a CH4N2S, that is thiourea. Sulfur in the MOS2 come from this thiourea, and the other chemical NH46MO7, that chemical is ammonium molybdenate tetrahydride. That is this MO coming from that ammonium molybdenate tetrahydride. You just mix two chemicals, put it in an autoclave, do that autoclave reaction, no, not autoclave, hydrothermal reaction for 200 degrees Celsius at 24 hours, you will get this thing. So I am thinking about in situ reaction. You can buy MOS2 directly from the market also. If your BTech students are saying like, sir, we don't have time for preparation of MOS2 and all. Okay, fine. Just buy MOS2 from outside, but it will be like, it is not going to have a good chemical reaction. Like if you see this picture, my CNT is going to get some coating of MOS2. This coating will never occur. Like this kind of coating will never occur if you buy MOS2 directly from the market. Maybe one or two layers it will happen, but you cannot control the thing. So that was the key thing, sir. In situ reaction was the key thing.
Okay. I didn't see that two chemicals in the top with the sulfur, and I was thinking,
Because
yeah,
it's much chemical oriented. I didn't want to take the study
oh,
or the section into chemistry side.
okay. Thank you. Now it's clear. So, participants, if anyone else is having any doubt, you can ask.
I don't think any questions are there, sir. I encourage all participants. If you have anything, you can ask me. Feel free.
Yeah,
Uh,
I'll do one thing. If anyone is having any doubt, you can contact me. I will give his phone number or mail ID. You can
Yeah, yeah,
contact
yeah,
him
yeah.
directly.
Yeah.
Okay. So with that, I'll wind up the session here. Thank you, Arun, for this wonderful session. I'm sure it was very useful for everyone who attended. And I'll share the feedback here. You can give the feedback, and if you want the contact details of Dr. Arun Sam Varghese, I will give you that also. So thank you. With that, we will wind up this session. For the next session, we will meet at 2 o'clock. The session is handled by Dr. Sebin Devase. He is again now he's taking a session purely based on AI, how to incorporate AI to measure interatomic distances and all. So see you back then. Thank you all.
Thank you everyone. Thank you for your time. See you all. Bye.
Bye.